Today we are going to learn how to find the image of a given object or given points using the matrix transformations. Dealing with the transformations, we are dealing with refraction, translation, enlargement, and the rotation. So starting with the refraction here, refraction. When you refract points, the point can be refracted either on x-axis, that is 1, or 2, either on y-axis, or 3 on y equals to x, on y equals to negative x. So in refraction we will deal with these points here. So the matrix transformation under refraction is given by this one, matrix transformation under refraction is given by x dash y dash means that this is the image equals to cos of 2 theta, sine of 2 theta, sine of 2 theta, and negative cos of 2 theta, then times the original point, that is x, y, y. So this theta stands for any angle that is, maybe that point is reflected. For instance, when the point reflected on x-axis means that x-axis theta equals to, on x-axis theta equals to 0, and on y-axis theta equals to, on y-axis theta equals to 90 degrees, and on x-axis y equals to x means that theta equals to 45 degrees, and on y equals to negative x, theta equals to 135 degrees. So if we reflect a point on x-axis, we check theta equals to 0 degrees, on y-axis theta equals to 90 degrees, and on y equals to x, theta equals to 45 degrees, and on y equals to negative x, theta equals to 135 degrees. So matrix transformation under reflection is given by this general formula. This is the general formula of finding the image of any point reflected on any line there. We see an example here. Find the image of the point 3, 1 when you reflected on y equals to negative x. Let's start with solution here. As we discussed before, that when a point reflected on line y equals to negative x, when 3, 1 reflected on y equals to negative x, means that theta equals to 135 degrees. Then by using this general formula, refraction matrix, that is finding the image x dash y dash equals to cos of 2 theta sine of 2 theta sine of 2 theta negative cos of 2 theta negative sine of 2 theta, then times the original point, that is x comma y. So our original point x comma y is 3 comma 1. So finding the image here, image of x dash y dash will be equals to cos of 2 times theta, the value of theta is 135 degrees, sine of 2 times theta 135 degrees, then here again sine of 2 times 3 135 degrees, negative cos of 2 times 135 degrees. Then this is matrix times the column matrix or column vector x is 3 and the y is 1. So here we get this one. Okay, 2 times 135 is 270. It will be cos of 270 degrees, and then sine of 270 degrees. Again here is sine of 270 degrees, then negative cos of 270 degrees times the column vector or column matrix. This is 3 1. So if we find the cos of 270 degrees from calculator, we get that 0. The value of cos of 270 degrees is 0. So this will be equals to, okay, let me write here. This will be equals to x dash y dash will be equals to 0, and then sine of 270 degrees is negative 1, and here also will be negative 1, and the cos of 270 degrees is 0. So we write 0 here. So we have this matrix, we have the reflection matrix times the 3 1 is column matrix, and then we get, if we multiply this row times column, we get here, what's the value here? We get 0 times 3 is 0, and then negative 1 times 1, we get negative 1, because 0 plus negative 1 we get negative 1. And also this row times column, negative 1 times 3, we get negative 3 plus 0 times 1, so we get negative 3 here, that is negative 3. Therefore x dash y comma y dash equals to negative 1 comma negative 3. So this is the image. Then the image of 3 comma 1 is negative 1 comma negative 3. So this is the answer. Thank you very much.